All right, so today we're going to start looking at some lessons you can teach using Algebra Tiles. We're actually going to be looking at these for the next couple of weeks, so that was why I had you have a part of the project where you either made/bought some Algebra Tiles. So I kind of adjusted and made my own out of foam. I already had some base 10 blocks, and I just kind of cut them up a little bit smaller. So but I wanted to show you at least, I mean, I know you're at home and you can't really get these, but I wanted to show you what a lot of the high schools and junior highs have. These are called Algebra blocks. I don't know if you can tell, but these are plastic, okay? And so these just have a whole lot more pieces. So I'm going to kind of show you some examples here. Okay. So these are all your x terms. So this is always the unit. This represents x. This is x squared because it is literally x by x. So it's literally an x measurement squared. Okay. And then this is x cubed because it is literally x tall, you know, x wide, x long, all that. Okay. But the cool thing about algebra blocks is there is a little bit more. So these are kind of going to be mirrored other than this one. This is going to be kind of what your algebra tiles have. It's just a little bit less rigorous, basically. The good thing about the algebra blocks, if you have them in your school, and I'll kind of show you how you can adjust this if when you get to your school you do have stuff like this. They also have a bigger set. So if you look at these oranges, notice they're a little bit longer than the x's. Okay, so these are what we usually reserve for the y's. Notice this is the unit, this is y, this is y squared, this is y cubed. Okay. So it just gives you kind of some expansion. You can actually mix x's and y's, okay, which in Algebra 1 you might actually want to do. And then last but not least, I'm going to leave this up here. We actually have these little light orange ones in most algebra block sets. So I'm trying to find all the sizes. So if you notice, they're kind of clever with their colors actually. Sorry, I'm trying to make sure I've got them all to kind of show you. So this is actually a mixture of the x and the y. This is literally x by y. This one has the shorter measurement here, so this would be x, and then the width is y. Okay, and then this is another kind of measurement of that. Notice these aren't the same size block. This one, I don't know if you can see it, but this one's actually a little bit bigger. But this one is the same measurements, just in a different way. Like this would be like the width is x, and the length is y, but the height is only x instead of the height being y like it is in this one. Okay, so here's where you could literally multiply the x's and the y's together. Notice it's like a light orange, a mixture of the yellow and the orange together. So I'm gonna go ahead and put those up. If we were in class, we would have been probably using these a little bit more than the algebra tiles, but it's cool. We can make do with the algebra tiles. That's kind of what this semester is all about, right? Making do. Making do with circumstances we don't really love. Okay, so let's go back to our algebra tiles, okay? Because I'll be using those for the rest of the time since I know that's what you'll have at home. Now my colors might be a little bit off, so what I did is my greens and blues are going to be my positives, and then my yellows and reds, I ran out of red basically. My yellows and reds are going to be my negatives, okay? So depending on how you kind of did yours. So before we start, you are going to need what we call the algebra block mats. So there's a positive, negative one. If you don't have a printer, you can just draw this. It's very simple, right? It's just a huge rectangle with minus on one side, plus on the other. Okay, you would just need to really accentuate the minus and the plus. Here's another one we're going to use today. Okay, this is the sentences mat. Notice that this looks like a balance with an equal sign in between them. So we're going to learn how to solve equations using this mat. And then finally, I don't think we're going to get to it in today's video, but probably the next video we will. This is a quadrant mat. Notice 2 of the quadrants are positive and 2 of them are negative. And so this is what we're going to use to multiply and divide things, to factor trinomials, to multiply 2 binomials together. So this is kind of the more advanced mat that I don't think we'll quite get to in this lesson. Okay, so if you need to, pause the video to get out these mats, but then also get out these algebra blocks. And then what I've also done is uploaded for you to print. Again, you could just draw this if you want, but if you have the printer and you want to print it, these are like little mini versions of the mats if you look. And so these are going to be what would be appropriate for you to do like homework on. Okay, so they're just like little tiny versions of the mats that we're going to look at. Okay, so it would be where, you know, you could fit more than one problem on a page because it's not very practical to only have one problem to a page, right? Okay, so I'm going to move my algebra tiles kind of off to the side here until I need them. So I want to look at the beginning of algebra tiles. So algebra tiles are one of the few manipulatives that we use in junior high and high school. You know, the elementary schools have a lot of manipulatives. They have pattern blocks for fractions. They have Cuisenaire rods also for fractions. They have base 10 blocks when they start talking about decimals, and many, many, many more. Okay, but you know, junior high and high school are a little less on the manipulative side, but algebra tiles is a really good exception where we can really get some use out of them and teach algebraic topics. So the first thing that you need to know is that a positive and negative value kind of cancel each other out. When paired up. A lot of the methods we're going to look at over the next week and a half or so are going to have that principle kind of at play. Okay, so I want to look at some simple ones first. So I want to look at the block math that's plus minus. Okay, and then I'm going to show you how to draw these too. Okay, and so I want to look at a couple of these. So maybe let's get out our little bitty block mat too.
Could you try again?
Sorry, my Siri is being crazy. That's not the worst thing Siri's ever done, but anyway. So the first one that I want to look at, now I'm going to write the problem kind of right on top of it. So I'm going to start kind of with an easy one, and we're going to look at how you would show 2 plus 4. Now we all know what the answer is to that, right? So I'm going to put that kind of off to the side because I want to use my big block. So what you would do is you start off with your first number. Notice I'm using my green because it's positive, right? And what I want to do is I want to add 4 more positives. Okay. Notice I would put them on the positive side if they're positive. I'll put them on the negative side if they're negative. Notice here that I now have 6 on the positive side. So of course we know that 2 plus 4 is 6, right? So when you're doing these on paper, you might want to get like a red pen out. I usually use red for negatives and then just black for positives. So what you had, and I'm going to show the little units not as squares but as little circles, and then I'm going to add 4 for a total of 6. Okay, so there's not really a whole lot going on in that example, right? But we had 2 of something, we added 4 more, and by the way, I use circles instead of the little squares because if you're not careful, if you draw this as a square, it can look awfully close to this if you don't know the size, right? So we usually use little circles for the units. Okay. All right, so that one's easy enough. Let's look at another one. That's pretty easy as well. So we're going to look at negative 3 plus negative 5. So I'm going to kind of squeeze that in here. Okay, so negative 3 plus negative 5. Okay, so notice the difference here is that they're negatives. So let me put my mat back out here. So we're going to take 3 negatives. By the way, you wouldn't have to use a different color here because with these mats, we're indicating whether they're positive or negative based on the mat. So, I mean, it's kind of questionable if you have to use your negative blocks, but I like to. Okay, so we have negative 3, and then we're adding 3 more negative 5s. And of course, notice in neither one of these last 2 problems did we have any pairs to kind of cancel out. We just have all of one color, all of one sign. So notice we end up with 8 negatives there, right? So coming back here, if we want to draw that, I'm going to not only draw it in the negative, but I'm going to draw it with red. So I have negative 3 plus negative 5. And of course that totals to negative 8. Okay, sorry if it's a little bit blurry just because my printer printed that kind of dark. Okay. But let's look at some subtraction problems, particularly where maybe we have to take away some negative numbers. That's always a little more challenging. So the next one that I want to do is, let's do negative 5 minus 2. Sorry, negative 5 minus negative 2. Okay, so notice here, I'm going to get my big block out. I'm going to start off with negative 5. So 1, 2, 3, 4, 5. By the way, it's helpful if you're doing these with me. And so now we want to take away or subtract 2 from the negative side. And notice we have 2 to take away. So how I show this when I demonstrate is that I just move it outside the box. I literally take them away like that. And notice what's left once we're done, 3 on the negative side, right? Now when we go to the color or picture version of this, we can just draw 5 in the negatives, and then we take 2 away for a total of negative 3 when we're done. Okay, but let's look at a couple that are kind of more challenging when we have students that don't understand positive and negative numbers. So what about 4 minus negative 2? Now, I know that we know that that changes to 4 plus 2, but you'll have a lot of students ask you why. Why does a double negative change to a positive? Okay, and there's actually a lot of students that will ask you that, and there's a lot of teachers that aren't able to answer that question. So kind of visually, we can show why that is here. So let's set that up. So we start off with 4. They're positive, right? So 4 on the positive side. And then notice what the problem's telling us to do is to take 2 away from the negative side, but we don't have 2 from the negative side, right? Like we don't have 2 over here to slide off of the mat. So what we have to do is we have to create what we need, right? So we're going to create 2 over here so that we can do the slide off the mat thing, but we can't do that without partnering that and adding 2 over here. Okay, so like these that I'm pointing out are the extra ones that I added, right? So, and I needed these 2 because the problem is asking me to take 2 on the negative side away. And notice that's going to leave positive 6. So let's see if we can draw that. It's a little more challenging. You know, the more challenging the question, the more challenging the drawing of it is. So let's start with our 4 positives. Okay, but then we want to add in. So I usually just write add or additional or something like that. I need to add in 2 here and then 2 here, okay? Because these have to be matched up, right? These have to be paired. And then I can do just what I was supposed to do, which is take these 2 away, right, for a total of 6. Okay, so when you have something that you're trying to subtract, really using any of these mats, and you don't have it, you're going to have to create it and then counteract that by adding a positive value as well. All right, so let's do one more like that, and then I want to look at maybe one that's really the same, but we're going to use the x's instead. But let's look at negative 1 minus negative 3. And again, we're going to fight the urge to just change that to a plus 3 because frankly, our students don't know why that happens, okay? And you need to make sure that you can explain why it is that that happens. So negative 1 minus negative 3. So we'll start off with what we were given, right? Which is negative 1. Now we're supposed to be sliding off or taking away 3 of these guys, and we don't have them, right? So what we're going to have to do is create a scenario where we do have them. So we add 2, okay? And then to counteract that or balance that, we add 2 over here. Okay, and then we slide off the 3 that we're wanting to subtract on the negative side, okay, leaving only 2 on the positive side. So the good thing about these problems is you should know the answer already, right? It's just basic arithmetic with negative numbers, but you need to make sure you know how to explain it, okay, know how to show it. So we started off with a negative down here, right? And then we had to add an additional, I don't know why I'm wanting to spell add with 1D, but whatever. Add an additional 2, right? But I have to counteract that by also adding an additional 2 here. Okay, and then I take 3 away on the negative side for a total of 2 positive. Okay, so let's look at maybe adding things with x in it. You're going to find it's not that much different. So what if I told you to take 2x and subtract off minus 3x? So 2x take away negative 3x. So we're going to start with 2x. Okay, notice we're using these this time, right? Because these are my x's, right? These, by the way, are my x squareds because, again, literally it's x by x, right? So I have 2 x's, and I'd like to pull away or take away 3 of these negative x's, but I don't have them, right? So I'm going to need to add 3 of those. Remember, I used yellow for negative because I ran out of red. But I have to counteract that by also applying 3 here. And then I can slide these away or take them away. Okay. So on the homework, you really need to make sure that you can show the thought process that you're thinking and kind of show the work, because clearly, like, I'm expecting that you already know what the answer is on 2x minus negative 3x, right? Like, you shouldn't be in this class if that was a problem for you, right? And that's not to be mean, I'm just saying. So you really need to make sure you're showing the work here. It's the work more so than it is the answer, because these problems are really elementary. Okay, so I like to show the x's just as slash marks, okay? Kind of like if you came from elementary math, we show the longs in the base 10 blocks like this too. Okay, so we started off with 2x, right? And then we wanted to take away 3x, so we needed to add 3 of these guys. But to counteract that, I needed to add 3 of these, right? And then I just take these away, slide them away for a total of 5x. Okay. All right, so that's pretty simple. The biggest thing that I want you to do when you practice this is just make sure that you understand that, for instance, adding a negative is different than subtracting a positive. Okay, it's different visually. So without getting into another example, if I asked you to add negative 2, that means literally add 2 in the negative side. Okay? But if I ask you to take away 2, okay, which adding negative 2 and subtracting 2 is supposed to be the same, right? But visually with these blocks, it's not the same, right? If I tell you to take away 2, then you're taking away 2 from here, right? So essentially, mathematically, number-wise, they're the same, right? Adding negative 2 or taking away 2 positives is the same, but visually it looks different, okay? All right, so now let's look at maybe some solving equations. So for this one, I want you to get out this map. Okay, so notice it literally looks like a balance. So we're supposed to make sure that the things or the balance stays equally weighted on both sides. Okay, and we're going to start with kind of some simple. Notice these are for solving equations because there's an equal sign. So let's say that again, let's get out our little mats. So the first problem that I want you to do now on these mats, usually we show it in stages. So like a whole row is going to be example 1 of this. So example 1 is going to be to solve x plus 3 equals negative 4. But it's not just one set, it's like the whole row. Okay. So x plus 3 negative 4 is what I want us to start off with. So the first thing we do is we just set up what we were given, right? We know that x plus 3 is supposed to be equal to negative 4. Okay? And your goal, by the way, your goal in any equation is to get this x all by itself. Okay, so you have to somehow kind of counteract what you've got going on here. So there's a couple of different ways to do this, right? And it's helpful if you think about what you would actually probably do first, right? So maybe we want to get rid of these guys, okay, because we want to isolate x, right? So how could we get rid of those guys? Well, we could pair them up with 3 negatives here, but notice we're adding those, right? So we can't do that without balancing it out on the other side. So I would take the current 4, right, and I would put in 3 negatives on the other side as well. But then notice we can pair these up, right? So remember what I said at the beginning of the lesson. Any pairs of negatives and positives kind of cancel each other out. Okay. And then notice we're actually finished with this one, right? This was just a one-step problem. So now we have that x equals -7. Okay, so all it is like a visualization of what you already know how to do anyway, right? Keep in mind that our students sometimes really like these hands-on activities. So rather than you just telling them, you know, hey, get the x by itself, subtract 3 on both sides, you're literally showing them that. So let's look at what the picture version of that would look like. So kind of the same, right? We start off with x plus 3 equals -4. Okay, so this one probably doesn't need a full row. Okay, that's okay. And so the first step is going to be, I'm just going to go ahead and show my step as a different little level here, just frankly because I have room to do so. So the first thing we did is we said, okay, first we're going to add in these 3. Okay, but I also have to balance or counteract that by adding in 3 over here. And then notice I pair up, right? So any positive negative combo cancels out, and I end up with an answer of x equals the 7 negative units. Okay, so I start off with x plus 3 minus 4, right? And then basically I end up with my answer, which is just x equals -7. Okay. So I kind of expanded out this, like you might be able to show some of this all in the same step, but there are going to be problems that are multi-step. Like that was really just a one-stepper. So let's do one where you certainly would need to probably do some sort of steps. So we're going to start with 2x plus 3 equals 11. So start off with 2x plus 3 equals, what did I say, 11? So you want to make sure you're trying to do these with me. It's different to do them on your own and to watch somebody do them. So okay. So the first thing is you might be tempted to kind of cancel out this way, but that's not really something that we've set up. So what we're actually going to need to do is say, okay, I want these 3 to go away because, again, I'm trying to isolate x, right? So I want to add in 3 negatives there, but I have to balance or counteract that with 3 negatives there. And then notice I just get these pairs, right? So pair them up. Mine's laminated, sorry, it keeps sticking to all my pieces. Okay, and so notice now we're left with these blocks, right? And then in the end, we really just want to know what 1x equals. So this is kind of visually how I show that. I just break it into equal groups. I think I must have had too many or not enough, right? 7, 10, oh yeah, I was missing 1 originally. So don't do that, right? But I never did have 11 originally, I only had 10, so my bad. I can't count, no big deal, right, for a math teacher. But in the end, notice if you separate them out like that, then you have that 1x is equal to 4, right? So we kind of have our answer. So you don't necessarily have to really show the division other than just grouping them, okay? So let's show kind of how we can show that visually. If there's pausing in between showing it on the little one, it's because I have to put all my pieces up. Sorry about that. Okay, so we started off with 2x plus 3 equals 11. I'll make sure I do 11 this time. Okay, so the first thing we did is we added in some negative counterparts so that we could cancel some stuff out, right? So we added in 3 negatives. So then we can do this. So then what we end up with, and I'm going to go ahead and draw it kind of how we positioned them, is 2 of these, right? And then I'm going to kind of 1 and 1 line them up. And then in the end, you could just do something like this where you circle the answer for what x is, right? So we do end up with x equals 4. Okay. So you can teach these in some different ways. You can have your students show different amounts of work, but I just like them to show what pieces they're adding and kind of the pairs that they're canceling and so on and so forth. Okay. All right, so let's look at a couple more. You know, for these, you might want to draw them yourself just because, you know, this is only technically 2 problems per page, right? I mean, it's better than the big map, but it's still not very efficient as far as paper goes, so feel free to just draw your own if you don't want to print it out multiple times. All right, so let's do 3x minus 1 equals 8. So 3x minus 1 equals 8. So we've got 3x minus 1, we got to put that on the negative side, equals 8 on the positive side. Okay, so notice we want to isolate these, right? More specifically, one of those, correct? But I'm not really necessarily going to be able to do that unless I can kind of pair them up, right? So in this case, there's a couple of different ways that you can consider doing this, okay? One way would be, okay, to say we're going to cancel this negative out with 1 over here and add it over there, or you can say, okay, I want to be able to cancel this red out with one of my greens. So I'm going to kind of add this in here, okay? But then to counteract that, I'm going to add 1 over here, okay? Notice it comes up with the same result. You're going to add 1 over here. So I don't really care how you would show that, but you need to show something to that nature. So let's start over. So we had 3x minus 1, right, equals 8, okay? So one way would be to say, okay, hey, I want to be able to cancel that negative out. So I'm going to add 1 there, but to counterbalance that, I also need to add 1 here, okay? And then I can group these 2 on opposite sides of the equal sign, and then do something similar to what I did last problem, right? So just split them up kind of like this. Notice if you do it like this, you can just kind of go 1 and 1, right? And so, of course, in the end, what we end up with is, if you just want to kind of think about one of the x's, right? And these aren't becoming negative. I'm just trying to slide them out of the way. So x is 3, right? So let's see if we can show that pictorially. So we started off with 3x minus 1 equals 8. Okay, so how we showed it, I'm going to go ahead and show it the way that we did, right, is we added 1 over here. We also added 1 up here. Okay, and then we didn't cancel these out because that would be kind of counterproductive, right? Like that would get rid of the step that we just did, but instead we cancel these out. Okay, so in the next step we have 3 x's, and then we're just going to line them up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 total, and then each x accounts for 3 of the units, right? So it's just x equals 3. Okay, so manipulatives usually aren't like the end-all be-all for your classrooms. It's just a good way to A, introduce a topic that might be a little confusing for your students, but B, to kind of help those hands-on tactical learners that really want to, you know, have their hands on what they're doing. So let's do one more. And then I think I'll save the next topic for the next video. So 4x minus 2 equals 3x plus 4. So that's got a little bit more going on with it, right? So 4x minus 2. So that's going to look like so. 4x minus 2, and then equals 3x plus 4. So algebraically, we can go in some different orders here. Notice if we're trying to isolate x, we have lots of different x's, right? So usually what we do is we take the side that has the most x's and we try to isolate those x's. So the first thing we can think about is, hey, we've got 3 of these on this side, right? And those can kind of counterbalance with 3 here. Okay, so essentially notice what I'm doing on both sides. I'm subtracting 3x from both sides, literally, right? I'm moving them up out of the way. Okay. And then we still want to isolate this guy, right? We still want to get this x all by itself. So in other words, we want these 2 negatives to go away. Okay, so there's 2 ways to do that. Okay, you can either say, okay, I want those 2 to go away, so I'm going to add 2 to both sides. Okay, so if I add 2 here, then I also have to add 2 here, but notice the purpose in that is because now these are going to pair up and move away. And then notice I've got my answer, right? It looks like x was 6. Okay. So another way to do that, just so you know, is we could have like gotten rid of the minus 2 first. Okay. But I like to model it like you probably would do it if you were actually using algebraic methods, and usually in that case with a problem like that we would probably get rid of the smaller x term first. All right, so let's show our picture for that one, and then like I said, I think we'll hold off on the next topic to the next video. So 4x minus 2 equals 3x plus 4. Okay, so the first thing we did is literally subtracted away 3 of these and 3 of these, right? So our next step looks like so. 1, we had 4 of these over here. I don't know why I drew them like that, but it really doesn't matter. And then we still have 2 of these. Okay, so then what I chose to do was I chose to add 2 here. But when I do that, I also have to add 2 over here. But when I add 2 here, I'm going to get rid of these, right? And then that's going to leave me with a single x on that side equals 6, right? So we just have x equals 6. Okay. Okay, so that is kind of the simpler version of adding and subtracting integers, but also some monomials, right? The thing with x's was they're each called monomials. And then solving kind of simpler algebraic expressions, right? Maybe 1, 2, or 3 step algebraic expressions, okay? Or equations. So next time we're going to look at how to multiply monomials together, and then maybe also how to start to factor using our algebra tiles. So anyway, try this on your own. By the way, before I move on, you are, for test 3, which is going to come pretty quickly after test 2, you're going to have to demonstrate to me in video form that you know how to do these different things with the algebra tiles. So you really want to be actively working these out with me.